So what is knuckle joint? Knuckle joint is a mechanical connector used to join two rods, which is not rigid, which is not neither fixed, which can be slightly rotatable upon some certain angle. For example, if we take two rods, which is horizontal and vertical, and it is fixed using a knuckle joint, and it can be rotated, but which is not rigid, but it is fixed one. For example, we take the steering rod, and further we explain the tension.
As Palak said, we will discuss about knuckle joint case study. I take as a steering rod, as Palak said, one is circular shape, another one is vertical rod. So for connecting those one, we will be using some knuckle joint, okay, knuckle joint connection. While knuckle joint, we can able to move either our particular direction, either left or to right, at up to certain degree. And then the main important things to notice while selecting the knuckle joint is material selection, and we need to analyze what will be made through knuckle joint and what are the load, how much load it can be able to sustain. So up to that, it can be analyzed from material selection, as well as it should be need to go for a heat treatment as well for analysis purpose. So further, Palak will explain.
So the knuckle joint is light and strong and reliable joint, which can be used for example. As I said, it is like it's a 20% of margin point. It is easy to maintain. First of all, it is easy to maintain. The capable for improvising the system, and it is used for it's mainly used for knuckle joint. For example, if you take the crane, which has high tension part. This part and this part is able to joint, but the crane hook is able to move up and down. The movement of the portion at a certain angle is known as mainly using knuckle joint. It is light and strong, and furtherly explained by Dakshi.
So as Palak said, the real world application is automotive steering rod. So for this, we need first some proper design. Before entering into any thing, we need some prototype as well as design. So for that, as already said, design and analysis must be done for knuckle joint. Up to that, we will be adding some finite elements analysis for this knuckle joint purposes, as well as the joint. The components used in knuckle joints are pin, fork, and eye wear dimension. So up to that, knuckle joint will be knuckle joint will have the capability to constrain the load. So further, Palak will explain.
So as the design was designed, we do the FEM, which is the finite element analysis. After the analysis, we go to the joint part, which is connecting the two rods, which is the high tension part. It's the high tension part. So while joining the high tension part, it carries the load, which is in the very heavy part. Which is very heavy part, and the load, the knuckle joint takes if the crane. We take the crane example here. If the crane part, the bucket is very weighted with the high tension. If the rod is connected to the bucket, there is a high tension movement fixed here. The movement up and down is take place here. Similarly, for the steering rod, the rotational axis and it is connected to the rod. So, while rotating towards left or right, the rotational of the rod also rotates, and the connection between the steering and the rod is called knuckle joint.
So as Palak said, we need to select some forged steel like SCA 4140. So that material we select for making the knuckle joint. Okay. So up to that we need to maintain for that knuckle joint. If we connect the steering rod, it must carry up to load of 1000 to 2000 kilonewton. We need to maintain properly, and we need to replace up to some particular period, or else it will give some impact and it will be able to have the chance to crack. If the crack happens, it will automatically lose its efficiency. So it will not properly work upon its principle. So that first we need to weld that material, proper design analysis, and we need to maintain that particular joint for best efficiency purpose.
So as a result, it is used to improve the efficiency and the strongness and we can reduce the failure risk, and as we are using the pin and shear truss. Thank you.